A few people haven't or didn't know how to enter their project onto the Blackboard. So under project, I created, oh, somewhere there's a video. How to attach your project to the discussion board. I made a short video to show you how to attach it. And starting tomorrow, you lose 5 points for each day it's not there. Next week, there's an exam, in class will be on Friday. The take-home portion will be due next Sunday.
Thank you.
Is there any questions so far? Okay, we were on this part of section 6.2. I think we did number one. I don't know if we completed it, so we'll go over it again just to make sure. We did find this formula, I remember doing it, but I think there were confusions on this one, so I wanted to start number one again. I know we didn't do. So it's saying, what you need to do is draw your normal curve and shade your area. Then find the Z values from the table. So to qualify for police academy, candidates must score the top 10% on the general abilities test. Assume the scores are normally distributed. We did this one. Is that what you said?
We did number one.
Yeah. I wanted to do it over just to make sure everyone understood it. Mean of 200. Standard deviation 20. Find the lowest possible score to qualify. So we want the top 10% and 10% written as a decimal. It's 0.1. We're finding the lowest value that 10% of the data would be above it. We know that it's going to be positive because these are broken into halves. So right here is already 0.5. We know it had to be in this half above 0. But when you look in the table, it's the probability below. So if this is 0.1, the rest of it is 0.9. So that's what you're looking for in your table. There's also on your calculator, we could do it using the table because that's what you'll need on the test. .9 here, these two. 0.9 would be between those two values. 0.8997 and 0.9015. This is only 0.0003 away. Here, it's 0.0015 away. So it's closer to this one. If it's closer to one of them, you take the closer. If it's right in the middle, take the large one. So it's closer to this one, we use this one. So our Z value is 1.2. Then this goes 0, 1, 2, 3, 4, 5, 6, 7, 8. This would be the nines. So this is the eights. 1.28. Any questions on that? Now, if you forgot and you looked up 0.1, as we started doing at the beginning, you get a negative value. You knew it didn't make sense. Formula. Oops, not Z. It's X. It's Z times the standard deviation plus the mean. This will get you your X. Into X. So you need at least a 225.6. I think to be in the top 10%. I might have cut it out, but I think it said if you were in the top 10%, you got $500, or maybe it's the next problem. Any questions on that? Let's try this. Go ahead and try number 2. Oh, it was the next one. A mandatory competency test for high school sophomores has a normal distribution, a mean 400, standard deviation 100. Top 3% of students receive $500. What's the minimum score you would need to receive this award? So draw your normal curve. This one will be similar to the last one. So we're looking for the top 3%. This would be 0.03. So then what would be the area under the curve below Z? Anyone? So from here, would be 1 minus 0.03. So we're looking for the closest value to 0.97. Or the exact value if they have it. between these two. It would be closer to this one than this one. This would be 0.0006 away. This is 0.0001. So it's closer to this one. So 1.8, and this is the second to the last column, so it's an 8. 1.88. Is that what everyone got?
Solidify X 1.88 times the standard deviation plus the mean.
So a score of 588 would get you the $500. Any questions on that one? The bottom 1.5%. The bottom 1.5% must go to separate score. What's the minimum score you would need to stay out of this score? So if we want the bottom 1.5%, are we gonna have our Z value above the 0 or below? Mhm. Because it's less than 5%, less than 5%, this is where, or 50%, this is 50% of your data and this is 50%. This area then is 0.015. Which means our Z value should be negatives. This is the bottom 1.5%. Should be pretty close to 0. Now notice that this is below our value. That's what our table uses. So you use this value. This one we subtracted from 1 because it was above. We needed below. This one's already below. So we use that 0.015. Oh, it's actually right there. It's exact. So sometimes they will be exact, which is nice. I took some from the book hoping it would. So 0.015 is exactly there. So it's a negative 2.1 and 987. So negative 2.17. Any questions on getting the value? Remember, if your a Z value of 0 is a mean of 400. So our number needs to be less than 400. Getting a negative, or not negative, a positive 183. So you need more than 183 to not have to take summer school. Any questions on that one? Part C. Think about how you would set up those two values for your middle 50%. What you want to remember is this is symmetric. So there'll be a value here, and there'll be one here. And there's going to be 25 on each of these because it's a uniform. So the middle 50% is going to land 25% on each side. That would give us the middle. But how do we find out what's here? If 50% is in the middle, what percentage is the combined outside? 50% is in the middle. How much is in the outside? The other 50%. But it's going to be uniform, so dividing it by 2, 25% would go on each end. So this has to be uniform. So this would be 25%. And this would be 20%. So 50% in the middle means there's 50% outside. And if we divide that by 2, 25% on each of those outsides. That way, then when we find this one, we'll use the percent below it. Then when we find this one, we'll use the percent below it. So I knew there was a Z on each side of the 0 because they said the middle 50%. So to find this first one, use negative. It'll be a negative value. We use the 0.25 because 25% of the data is below that first Z value. 2. So find the Z value for 0.25. And if you need to open up the table, you can go under the book, 6.1 or 6.2, it's table E. Or you can open it through my MacBook. Oh, no, we have Alex, through Alex. Here. So is it closer to the 0.2514 or the 0.2483? If you take this and subtract it from the 2.25, so you can just subtract your value to find out which one it's closer to. It's closer to this one. Not by much, but it's closer. So we use the 0.2514. Go across, negative 0.6. $987. That would be the Y Z value. Find the higher Z value. What percent is below this value? Anyone? 25, 25, and 25, 75. So 0.75. So it's between these two. Which one's it closer to? Closer to this one. Getting the same value, only positive. Because this is uniform, these are going to be the same value. One is going to be positive and one is going to be negative. So when these are an equal percentage from 0, your Z values will be the same, a positive and a negative. You just need to find the X value. They erased the mean and the standard deviation. Yeah, it was 100. So the middle 50% of the scores are from 333 to 467. Any questions on that? There'll definitely be one like that on the test. The mean temperature in Pittsburgh is 73 degrees. Assuming a normal distribution, what would the standard deviation have to be if 5% of the days have a temperature of at least 85 degrees? We can just. We can use the formula, there's a couple we could use. Okay, so if you look at this formula or your regular Z-score, to find the standard deviation, we need X, we need Z, and we need the mean. So we need to find Z. Because we have X and we have the mean. For sure, at least 80. Assuming the distribution, what would the standard deviation have to be if 5% of the days have a temperature of at least 85? So at least 85 would be 85 or more. So our 5% would be here. So we need to find this Z value. Any questions on that part? If this is 0.05, is this the value we're gonna look up on our table? No, because we need the below, right? So we're gonna take 1 minus 0.05, which is 0.95. So this is the value we're gonna look up in our table. What happens here? Is it closer to one of them? Right in the middle of them. So you take the larger. Last we get 1.6. So 0.95 is right in the middle of these two. You take the larger. So it's 1.6, and then this would be 0, 1, 2, 3, 4, 5. You can just plug in. X was 85. We just found Z. We're looking for the standard deviation. And the mean was 70. How would we solve? What would we do first to solve for the standard deviation? Anyone? You need to get this by itself. So subtract the 73. Dividing by the Z value, we get the standard deviation equal to the 2.7 keeps repeating. Normally, it would match the mean in decimal places, so it would be 7. On a test, I would probably specify for this one. I would think Alex will want the same units as your mean. But I would, if I didn't specify, I would take 7, 7.3, or 7.27. I would take any of them if I didn't specify. Rule of thumb, it's one more than your data, but this is a little different problem. Any questions on it? The calculator. This room starts getting hot, so kind of be prepared for that. Doesn't matter how low I turn the thermostat. When you're, this one doesn't do that. Let me find one. Wanted to have the percent and calcium levels in people are normally distributed. Oops. With a mean of 9.5 and a standard deviation of 0.3. Individuals with calcium levels in the bottom 10% of the population are considered to have low calcium levels. Oh, this isn't, oh yeah. Find the calcium level that is the borderline between low calcium and carry out your computations. But the bottom 10%. So first you would make a curve showing the bottom 10%. I hate this little space. They need to move this down. So the bottom 10%, remember, up to here is 50%. And then this is the other 50, so the bottom 10% has to be over here. Now, if we use our table, then we would be using this value, right? Because it's the bottom part. So let's look at the table first. I haven't tried the calculator out, so I want to make sure we have the right values. Point. No, further. Yeah, that's right. 3, it's closer to this one. So our z value would be negative 1.2. Nine eight. So negative 1.28. Now the calculator. Click it over here. And you use this z here. And then you put your 0.10. The only thing is it's not giving you the negative. You have to know that it's negative. So you have to be careful of that. So if you are using the calculator, you use this z, and then you put the percent below 0.1. And it gives you the value, but you need to know that that would be a negative z because it's the smaller percent. It would have to be more than 50% before it hits the positives. Any questions on that? Because below a negative 1.28 and above 1.28 is the same percentages. So it's giving you a positive, but the answer for z is negative. Any questions on that? So with the calculator, you have to be careful. The table used to only give positives, but now it does both. The newer versions. Any questions on that? And then you still find your x value. Point 3. Do you like the calculator or the table? You just have to be careful with the calculator. It said round 1 decimal place. 9.116, which would be 9. Any questions on that? Any questions on that? You need to do more on Alex or are you okay with these problems if I move on to the next? Or do you need to do more of these? Preference? More of these? According to our doctor, Mrs. Nelson's cholesterol level is higher than only 10% of the females age 50 or over. The cholesterol levels for females age 50 and over is approximately normal with a mean of 225. and the standard deviation is 20. What is Mrs. Nelson's cholesterol level? Carry your immediate computation to at least 4 decimal places and then round to 1 at the end. According to her doctor, her cholesterol level is higher than only 10% of females. So think about the curve and where you would put that. So the level is higher than only 10% of females. Oh, well, we're at the 10% here. So would it be down here or would it be up here? Above or below 0? If she is higher than only 10%, would it be up down here or up here? She's higher than only 10%, so 10% is below her. Maybe this one. Because she's higher than only 10%. Here's the first 10%. So this would be her Z value. We already found it. It's going to be the same when you have the same percents. So the wording is where you're going to get tripped up. It's not that the problems are that hard. Just be careful. So it said 10% was below her, or she was higher than only 10%. So this is higher than only 10%, which we already found that Z value. So then we would just take our X. Z times the standard deviation plus 3. Surprised they did that and didn't actually find another one. Any questions on that? See if they give us any. So suppose the score on a particular test is normally distributed with a mean of 110 and a standard deviation of 16. So decide where our 15% is. Is it in the top half or the bottom? What is the minimum score needed to be in the top 15%? Top 15 means there's 15% above you. So that would have to be here. So then would we use this value when we're looking it up? Because we want the percent below. Always need the percent below. So 1 minus 0.15. 0.85. Table or calculator? Calculator. And it's not too big of a deal because we're over here, it should be the positive value. Remember, if you're at this end, it's negative. So we'll put on easy. Why did I give it? Oh, shoot, I know why. I forgot. I read this last night, but forgot. These Z values do the opposite. Yeah, so that was the other thing that was confused. I knew there was something else that I wanted to discuss on the calculator. So this is the opposite of the table. This one, you put the percent above. That's why we're getting the opposite value. Notice if I put 0.15. You get the positive. So you need to be careful when you're using the calculator, it's above. When you're using the table, it's below. So that was the other thing. I forgot about that. You're still getting the right Z value, just getting the sign. So be careful of that. The table uses below, the calculator for the Z uses above. But then this still gives you the percent below. I don't know why they did that with the calculator. So if you're gonna use the calculator, be careful. The Z value will just be the opposite sign. Any questions on that? We have to stop there. Don't forget tomorrow, I have a little bit to teach and then you can ask me questions on.
I need help. I'm trying to one.
Okay.
Hang on. Okay. So this is 0. Think of a number line. If your Z is over here, it's positive. So it goes 1, 2, 3, 4, 5. This way you go negative, -1, -2, -3. So if Z is over here, it has to be positive. If it's over here, it's negative. Think of like your regular integer number line. So it goes 1, 2, 3, 4, 5, 6, and going this way, -1, -2. Okay. If you don't have any questions, I will see you tomorrow.